Welcome back to my channel. Uh, this moment I want to share again about the problem solving or answer and solution of the Cambridge International SNA level. Yeah, this is a paper one, multiple choice. Okay, we go directly to solve some problems, probably 40 numbers. Yes, this is the paper. Okay, go to number one. The student grade table show reasonable estimate of some physical quantities, which the row is not reasonable estimate. Okay, we have quantity and value. Is it electric current in the fan heater is 12 ampere? Yes, I think this is reasonable. Mass of the an adult person around 70 kilogram. Yes, also we also about 78 kilograms. Maximum speed of an Olympic sprint runner. Oh yeah, around 10 meter second minus one. Yeah, one in 1 second around 10 meter. I think it's reasonable because use the Olympic sprint runner. And D, water pressure at the bottom of garden ponds. Yeah, I think it's the not reasonable estimate because if we know about the pressure on the atmospheric pressure is around 10 to the power of 5, but here is 10 times to 10 to the power of 5. It's not reasonable. Yeah. So I think the answer is uh, D. Yeah. Number two, which expression has a same as I base unit as pressure? Pressure actually force divided by area, or what we have force is around mg and area is a capital, or area is length times length. Yeah, let's say this is about L square, and then we have uh, G is meter second square, and then after that we can cancel about the, yes, mlt square. Yes, I think the answer is, you can see this is mt square over length. Go directly number three. The speed v of a liquid leaving a tube depends on the change in pressure delta P and the density rho, the liquid, the speed given by equation. Where K is constant that has no unit, what is the value of N? If you know about the delta P per rho is in the root, so N equals to root. The root is the power of a half, so we get the number of N equals to a half. Number four, which row correctly describe quantities, momentum, power, and temperature? Is it momentum, scalar, or vector? Power also on temperature. Momentum has direction, so we get the momentum is in a vector. Power is force. As our power is force times velocity. Force have vector and velocity also vector. Vector times vector becomes scalar. Yeah, and then temperature also, this is scalar because no direction in the temperature, so the answer is C. uh Number five, a girl throws a ball vertically upward. It takes them of 3.20 seconds to return to her hands. Assume air resistance is negligible. What is the initial speed with which the ball thrown? The ball start from the her hand until back to the her hand. They have two times until the high maximum height. So if we see the total, if we see the time until maximum height is a half of 3.2 second. So if we divide it, this 3.2 divided by 2 is equal to 1.60 second. So velocity equals to VO plus AT. A is gravitational acceleration around 10. If we calculated 10 with 1.6, it around 15.7 meter second. Yes, this is the answer. Is this is actually from GT. G, let's say G is okay. Let's say G is 9.81 and times with 3.20 divided by 2, it's become 15.7 because this is G and this is a time until the high point. So, number 6, a radio controlled by car travels along straight line for a time of 15 seconds. The variation with time t of the velocity v of the car is shown. Uh, this is about the what we call it the area is distance, yeah. So if we see this is the graph of velocity versus time, so we get this is the area is distance, yeah. Area is 3 times 10 equals to 30 meter, and area of this is 5 times with 6 equal to 30 meter also. So if we see um, velocity equals to displacement over time, the displacement equals to 30 minus 30. Why 30 minus 30? Because the direction is opposite. When the object come to 10 seconds, the object will go back in the other direction, the opposite direction. So the displacement is 30 minus 3. 30 minus 33 become to 0 and divided by 16, it's become 0 meter second. So the answer is B. Okay. Number 7, the election of free fall of Pluto is 0.66 meter second minus 2. An object weight 6.0 Newton on Earth. What will be the object weight on Pluto? So we know about the weight, which equals to mass times g. When the object on the Earth, we get mass. Mass equals to weight divided by g. Mass is sorry, weight divided weight 6 Newton divided by 9.81, and then after that we get mass with times also with gravitational acceleration on the Pluto. So we get 6.0 divided by 981 as the mass of the object times with gravitational acceleration 0.66, it's become 0.4. Okay, the answer is A. Continue number 8. A stationary fireworks, yeah, explode into three pieces moving the same plane. The masses and the velocity of the three pieces immediately after the explosion are shown. If we see this is object from the one object into three objects, yeah. Uh, V1 is 5 grams and make the Angle with horizontal plane 60 degree. Also V2 also mass 2 has 50 grams and make a degree with the horizontal plane 60 degree, but others mass 100 grams uh, to the to the to the down and with velocity 8. So if we calculate, this is about the direction on the x axis, v2 cos 60 equals to v1 60. So if we cancel it about cos 60 and then we get f1 equals to f2. And then on the y direction, we have v1 sine 60. Also, we have v2 sine 60. And on the y direction, negative direction, we have velocity is 8. Yeah. If we use the momentum, conserve that m1 v1 sin 60 plus m2 v2 sin 60, it's equal to this object, yeah, 100 times with 8. So if we calculate v1 equals to v2, it's become 9.2 meter second. Yes, the answer is B. Next question. An object drove at the time O from a high building, a resistance is significant. Three grabs are plotted against time. Where the grab is the height of object above the ground, the speed of the object, the magnitude of resonant force of the object. R is X, Y, or Z. So if we see a height of the object above the ground, the height it will become to 0. So we can destinate about the, if the we come to 0 is on the graph x, yeah, it's at this point 0. And speed of the speed of the object will be increases until they hit the grounds. So we can see the z is the when the velocity is going up and the maximum point z. And of course the magnitude of resultant force on the object is y, because the result is going down, yeah, until the hits the ground, but no with the ground until the minimum value. So we get the answer is B. Number 10, an object hangs by means of the cords around the rods as shown. Yeah. The rod 1 we have F1 and the rod 2 we have F2, and the object with weight 10 Newton as the star. The object is held in the equilibrium by the forces F1 and F2. The object weight 10 Newton. There is negligible friction between the rods and the cords, yeah, which the rod table given the angle theta of 90 degree. This is the right angle. Yes. If we see, it's regarding of the object weight, this is the result force 10. Yeah, if we know about the resultant force 10, it's become of 8 and 6 Newton. So the answer is around 8 and 6 Newton. Where the 6 and 8, yeah, I think the f1 it will less than of the f2. Then f1 this is about 6 and the f2 about 8. So the answer is, this is not correct. I will change into 6 and 8. The answer correct is C. So number 11, with the forecast of different hydraulic pressure, which force is caused a difference in hydraulic pressures? Yes, this is about the friction. Upthrust, viscous, and weight. This is all on the uh, on the water, on the fluid, yeah. But the friction is doesn't does this is about different. This friction is maybe on the rough plane, yeah. Okay, number 12. A car mass 1,400 kilogram is traveling a straight horizontal road a constant speed of 25 meters second minus 2 minus 1. The civil output power from the car engine is 30 kilowatt. The car then traveled up a slope at 2.0 degree to the horizontal, maintaining the same constant speed. Yeah, the constant speed is 25 meters second minus 1. Okay, what is the useful power of the car engine when traveling up the slope? For the first, where the car is not on the sliding up on the angle with the horizontal 2.0 degree, we have that power equals to force time velocity. So we get force equals to power divided by velocity. Power is 30 kilowatt and divided by 25, it's equal 1200 newton. So we want to use this force into the condition later if the cars inclined up on the angle 2.0 degree. So we have power. Same with the formula before, power is equal to force times velocity. But differences is velocity as a difference about the force. We have force minus mg sine theta, so we get power equals to force minus mg sine 2 times with velocity. Power equals to force, we get a force equals to 1200 newton, and when we put here, and mg is, this is mass 1400, g is 9.81 times with sine 2 and times with 25, we get the power equals to 12, we get the 18,000 watt or 80 kilowatt. So the power useful on this condition is the power uh, output 30 minus power when we the inclined 2.0, and then we get 30 minus 18, and this we got 12 kilowatts. So the answer is 12 kilowatt. Now question 13. The diagram shows for force applying the circular object key, which row describes the resultant force and center Q on the object. Force, we have of the y direction, yeah, 45, and as also 45, it will become to 0 on the y direction. But in the x direction, we have 30 newton in the x positive, also 30 newton on the x positive, so we get the resultant equals to 60 newton. So the resultant force is not 0. What about the torque? Torque, if we see the 30 newton, 130 newton is the opposite direction. This is clockwise, and this is clockwise, and 30 newton is anti-clockwise. So the torque of between 30 newton here and 30 newton in here becomes 0. What about the 45 newton here? 45 newton, it's the same direction on the clockwise, in the clockwise. So we have the torque is not 0. This is 45 plus 45 times with radius of this ball. Okay, the answer is resultant of torque also not 0. Yeah, answer is A. Number 14. A uniform horizontal footbridge is 12.0 meter long, the weight 4,000 newton. It rests up to support X and Y as shown. A man of weight 600 stands at distance of 4.0 meter from support X. What is the upward force on the floor from support X? So We have calculation, yeah, about the system force between on this bridge, yeah. If we see support x is fx, this is like some normal contact force on the point x. And then for meter right, the man standing on the bridge with weight 600 newton, and also this is the weight of the bridge around 4000 newton, and the end of the right side with support y is force w. This is as the normal contact force of y point. So if we use y as the pivot, as the point when the all this force uh, work, yeah, anti-clockwise or clockwise, we see that fx on the distance 12, fx distance with support y is 12 meter, equals to 600 times 8. 600 this is equals to 12 minus 4, it's 8. The distance between this man until the pivot is 8, and the weight of bridge 4000 times with 6, yeah, this is system is a half of 12 6 meter. So we calculate this 600 times 8 plus 4000 times 6 and divided by 12 equals to 2400 newton. So the answer is C, 200 for 2400 newtons. Number 15. A metal block has a mass 750 grams. Magnesium makes up 60% of the mass, and the remaining 40% is copper. The density of magnesium is 1.7 grams centimeter minus 3. The density of copper is 9.0 grams centimeter minus 3. The question is, what is density of the block? So, as we know about the density, density is, yes, density is mass divided by volume. Yeah. So if we see mass, use the this formula, then density is mass divided by volume. So we get mass is density times volume. Yes. So the density of magnesium equals 1.7, and volume of magnesium 0.6, volume, total volume, because 60% of volume. So we get 1.02 for V, mass of Mg. What about mass of copper? Copper is density times the velocity of copper. Density of copper 9.0, and density for volume of copper 0.4 volume. So we get 3.6 volume. Then density blocks, yeah. Uh, it's back to equation of the density equals to mass to volume. So we get, this is mass of mg, this is mass of copper, and divided by v, so we get 4.62 kilogram meter power 3. The answer is B. Question 16. A man climbs slowly at the steady speed to the lobe of a ladder. Yeah, what is the means energy transfer taking place for the man as he climbs? This is about chemical potential. Let me decide it first. This is wrong or correct answer. Or chemical potential to kinetic, or kinetic to gravitational potential, or thermal heat to kinetic. The man has, the man already have kinetic energy and already have potential energy. It's not changed from potential from kinetic energy into potential, but it's like energy from her body, from his body, to change into potential energy. So it's about the chemical potential of his body. So I think the answer is chemical potential to gravitational potential. The answer is A. Continue number 17. A bit is received from rest at point P and sliding along a wire as shown. Okay, a bit from P without velocity, so we know if without velocity kinetic energy equal to zero. Then potential energy equals to mgh with mass m, gravitational acceleration is 9.81, and height is 8. So in term mh, the potential energy on the point P equals to 9.81 mh. Then the condition 2 on the point Q, the bit has velocity 1.4 meter second minus 1. So the kinetic energy is a half mv square, I will, after we calculate about these numbers, so we get 0.98 m, not meter, but this is about mass, yeah. So the potential energy equals also mgh. G is 9.81 and H equals to 40 centimeter. We change into meter, this is become 0.4 meter. So we'll calculate about the 9.81 times 0.4, this is around 3.92 m. So, from the energy conserved about the mechanic energy, that potential energy plus kinetic energy in the point 1 in the point P equals to kinetic energy plus potential energy in the point Q. So we get 0 plus 9.81 mH, 0 plus 9.81 mH equals to kinetic energy here 0.9 mm plus 3.92 m. So after we calculate it and simplify these numbers here, we get 9.81 h equals to 4.9. And then finally, we get H. It's around 0.499, or so around if we round off, this is around 0.50 meter. Continue to number 18. A mass is thrust vertical. In time t, the increase its gravitational potential energy is EP. In the increase its kinetic energy is EK. What is the average power input the mass here? Because in the same time the mass have potential energy as a gravitational potential energy, and also the particle has kinetic energy. The energy is sum of the potential and kinetic energy, and the ratio we divide it by time. So the correct answer is D. EP plus EK, or potential energy plus kinetic energy divided by time. Number 19. Water flows from the lake into turbine that is vertically distant of 90 meter below the lake at sun. Okay, the mass flow rate 2,400 kilogram per minute. The turbine has efficiency 75 uh, percent. What the output power of the turbine? If we see power times equals to efficiency and potential energy. Yeah, this is about the efficiency. Efficiency is total power divided by mgh, or efficiency times Mass equals to density time velocity time volume times with g times with also h. Yeah. So P out equals to, because time here we move into the other section as divided. So we get efficiency time density V over time GH. And then V over time GH, yeah, equals to, this is about flow rate to 1400, but in kilogram per minute we can change here into divided by 60 d 60, and we calculate first about this. No, this is not as the correct answer, because in this is in minute, yeah. So we get calculate this uh 0.75 times, this is around 4, 4 times with 3.4 become 3, 3 times 9, this is around 20. Oh, this is 9.81. So we get around 26 watt, or this is around 26 kilowatt. Okay, the answer is not here. I think this is the wrong, because we don't calculate about the, this is the flow rate in minute, not in second. Okay, we'll continue number 20. Wire diameter D and length L has vertically from a fixed point. The wire is extended by hanging a mesh M on the its end. The Young modulus of the wire is E. The acceleration of the free fall is G. What equation it used to determine the extension X of the wire? So, we have know about the equation in Young modulus, or uh, elasticity modulus E. E, then E equals to force times length divided by area times extension. Force is mg, length is L, and area is PR square, and extension is X. Uh, uh, I write his by, and R is D divided by 2, R divided by 2, this is R square, and then X is extension. So if we simplify about the 2 is going up, become 4, and MGL still here, and then PD is square, yeah, times X. So this is the same thing with this equation. So the answer is C. We'll continue to number 21, and number the letter. But don't forget to comment, like, and subscribe. Don't forget to comment, like, and subscribe on my channel. Then, continue to the next number. Number 21. A wave has period T, wavelength lambda, and amplitude A. The wave is shown on the graph of the displacement x against distance d. What, which graph is correctly labeled? See the graph A. If the A is the correct answer, yeah. This is amplitude is correct, yeah. This is complete correct. And then the lambda is, yes, is also the this is correct, yeah, because this is in D, not in T. Yeah. This is in distance, not in time. And then here, this is period. This is the wrong way because this is distance. This is answer is the correct answer. And this is amplitude. This is wrong answer because this is two amplitude. This is period. Also, this is wrong way. Why? This is the distance. And this is lambda. This is correct. But this is not correct. Not correct because this is two amplitude. So we we know this the answer is A. The correct answer is A. Number 22nd. A vehicle emits sound of the constant frequency. A stationary observer hears the sound. The vessel moves directly toward of the observer at a constant speed. The observer hears sound of the frequency F-O. The vessel then accelerated, still moving towards the observer. Travel at a high steady speed for a time and then decelerate until it stops. What is the variation frequency of the sound heard by the observer? Yes, the condition first, if the vessel emits sound with constant frequency and towards the observer on the constant speed, so the observer frequency will be rise. Why? Because the vessel come to observer. Then remedy state then returns to frequency FO. Why? Because the vehicle travel a higher sled speed for time decelerate until it stops. Yeah. Until it stops, it's become back to frequency FO. So the correct answer is D. Number 32. A car traveling in the straight line, the speed 30 meters second minus 1, passes near a stationary observer while sounding its home. The frequency of sound emitted by horn is 400 Hz. Yeah. The speed of the sound R is 336 meters minus second minus 1. What is changed the frequency of the sound heard observer at the car passes? When the car passes, we know about the car. Car is going near with the observer and so far with the observer. So delta of frequency is same with the source sound is come minus when the source is go away. Delta force equals to V velocity of sound 336 time velocity. This is times frequency. This is 400 hertz, and times with 1 divided V minus V source. This is when the source sound is going towards to observer, and this is it when the sound source is go away from the observer. So if we calculate the 1 divided something 1 divided something, we use the calculator, so we get the delta f around 7 8 hertz. Continue number 24. Which also electromagnetic wave in order increasing frequency. The high frequency in gamma rays and the low frequency in radio wave. So directly we think the correct answer is B. This is the wrong. Gamma ray is not here, yeah, because ultraviolet and infrared is on the between radio wave and gamma ray. And C is gamma ray is wrong if here because gamma ray is high frequency. And D, this is radio wave is wrong because radio wave is slow frequency. It will be going here. Yeah, the answer is B. 25. The diagram shows steel wire fixed on the one end. The other end is attached to weight hanging over a pulley. An oscillator is attached to the wire near the fixed end. A stationary wave with one lobe is produced the frequency of frequency SF. Which frequency of the oscillator produce a stationary wave with two loops? Okay, no. If with two loop is same thing with two times the frequency before. So if the frequency before is F, yeah, two loop if two loop is equal to frequency 2F. So the answer is C, 2F. Question 26. When the statement give the condition that enables diffraction to occur. Of course, this is about the wave blocked with obstacles, yeah. Not as the if the a source wave move towards stationary object. No, this is about the Doppler effect. This is Doppler effect, and the coherent wave superpose. This is the about the superposition wave. Indeed, two waves traveling through the same medium in the opposite direction. This is also about the superposition wave, but that's the wave it become not as superposition with the amplitude become to zero. Yeah. Destructive wave, destructive superposition. Number 27. A parallel beam like wavelength 600 nanometer is incident normally of diffraction grating. The grating has 300 lines per millimeter. What is the total number of intensity maxima from the grating? We use this formula d sin theta equals to n lambda. So this is equals n is line per millimeter. We have 300 lines per millimeter, so we put in 300 millimeter. And maxima intensity when the sine theta equals to 1. Yeah, when the theta equals to 90 degree. And n is the order of the how many intensity in the grating. And the lambda provided with 600 nanometer. Actually, we need to change millimeter into meters, millimeter into meter, and nanometer also into meter. But we can see this is around, if we calculate, this is around n equals to 5.55. Yeah, then the total number of density is two times because the if the on the diffraction grating there are one order equals to two line. It's about dark and light, black on white, black as the dark, white as the when the grading is on the maximum superposition. So we get total number of intensity is 2 times 5.55. Yeah, it's become to 11. The answer is 11. So question 28. Before we continue, don't forget to subscribe. Before continue, don't forget to like or comment on my this channel. A pattern is interference is produced using the red laser, a double slit and screen. The screen is 3.5 meter from the double slit. The light from the laser has a wavelength of 640 meter for 640 nanometer. Sorry, the pattern is fringes is shown. This is 7 millimeter, and we have about the n is 1, 2, 3, 4. Yeah, so use the formula dp divided by l equals to n lambda. D is what we will find, yeah, because the separation of the slit is d. P is 7.72 millimeter, yeah, in millimeter. We can substitute into meter times width 0.001, because millimeter, because 1 meter equals to 1000 millimeter, and divided by 3.5. 3.5 is the distance between screen and the double slit, and n equals to 4. We have 1, 2, 3, 4, and this is wavelength 640 nanometer. The nanometer is equals to uh, 10 to the power of minus 9. Yeah, so after we calculate blah 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 until we get d equals to 3.1, 10 to the power of minus 5. Yeah, the answer is C. Number 29, the diagram show the symbols of a wire cutting the current I. What does the current represent? Yeah, current equals to flow of charge on the several time. Yeah, or we decide this is the charge flowing past a point in the wire per unit time. The answer correct is A. How about B, C, and D? Let's say B, the number of electrons flowing past the wire per unit time. It's not the flowing of the electrons, yeah, because the direction of the current, yeah, is opposite with electron flowing. The number of positive nuclei, no, positive nuclei hasn't moved. Yeah. D, the number of proton flowing, no, the proton are never flowing. If the flowing, there will be no bombs. Okay, the answer correct is A. Number 30, an electric current I is given by the formula I equal A N V Q. What does its symbol represent electric current metal work? Ah, yes, it is about the cross-section area. Yeah. N, number of free electrons. Yes, correct. V is it voltage or speed? This is about voltage. Yeah, voltage. And Q is charge. Charge of each electron. So we can choose the best answer is A. Number 31. With the value of current and resistance will produce a rate energy transfer of 16 joule seconds minus 1. This is about the, we know about the power equals to I square times R. Yeah. How about if the power is 16? Yeah, it's also, yeah, we know, but this is 2 times 2 times 2. Yeah, 2 times 2 times 2, you become 2. Oh, sorry. This has become 8. 2 times 2, 4, or 2 times 4 times 4 times, no, no. What is the problem? Red energy transfer 16. Oh my god, there is no answer, because 2 times 2 times 2 equals to 8. Yeah, okay, there is no answer. We will see again on the later of my video. Number 32, a coil constant N turns insulated copper with wound on the cylinder of diameter D. The copper wire has diameter D and resistance of copper is rho. Diameter D is much greater than diameter D small. Yeah. What is the total resistance between the two ends of the coil of copper wire? Yes, this is if one loop. This is about the turn, how many turns it. But if the several turns in the n turns, we calculate n turns into this equation. R turns times rho and diameter and divided by area. So if we see turn is on, capital rho, D, capital D, and this is area is PR square. P R equals D divided by 2, R is equal divided by 2, so 2 times 2 equals to 4, we going up and then become to 4. So 4 N is turn, this is rho, D, D capital, and divided by D square. Okay, the correct answer is A. So number 33. Two cells are connected to the load resistor of resistance 3.0 ohms. The electromotive force EMF and the internal resistance of each of the cell are shown. Yes, I equals to total voltage divided by total R. Yeah, total voltage because this one way of the polar in the element. This is if we see this is positive negative, this is also positive negative, and this there is no different way. So we get the voltage equals to 6.0 plus 3.0, and resistor because this is on the series circuit, so directly way some rest, this is 0.8 plus 1.2 plus 3, so we get 9 divided by 5, yes, around 1.8 ampere. The answer is C. Continue to number 34. Don't forget to subscribe, comment, and like. The diagram shows a simple circuit. Which statement is correct? Yes, I actually choose A. When switch S is closed, the EMF of the battery falls because work done against the internal resistance of the battery. Or about C, B, or D? Yeah, when switch C is closed, the EMF of the battery falls because work done against the resistance of R. No, this is work done against the internal resistance of battery. So that's why we need the resistance of battery. See, when the switch closed, the potential difference across battery falls because work done. No, never different across the battery. Never potential difference across battery. D, when which S is closed, the potential difference across battery falls because work is done against the resistor of R. No, there's no correct answer. Number 35. Yes, this is about the circuit series in parallel. Six resistor is resistors R are connected as shown. The combined resistor is 66 kilo ohms. What is the value of R? So this is R. This is combined to R, and we get about the parallel is equals to R divided by 2. And this is parallel of R. So we get complete of this circuit equals to R divided by 3. So this is series. So 66 is series for R plus R divided by 2 plus R divided 3. And blah and blah and blah, and we get the R equals to 22 kilo ohms. Yeah, the correct answer is C. Number 36. We still have 5 numbers more. The cell has a constant electromotive force and constant internal resistance. The a thermistor is connected between the terminal of the cell. The temperature of thermistor is increased. Yeah. Which statement above the charge of the cell terminal potential difference or PD is correct? I just the answer is B. Yeah, before we made the videos, I just answer every single question. Yeah. A, the terminal PD is decreased because more work done moving unit charge stroke the internal state of the cell. No, because the work done moving unit charge, the potential is not decreased, but potential difference is still same with before. Yeah. B, the terminal PD is decreased because the current external decrease. Yes, if the terminal decreases, the potential difference will decrease. C, the terminal PD is increased because more work done moving charge stroke the thermistor. No, not will be increased. Yeah. D, the terminal PD is increased because the current in the transistor is increased. Yes, I think the correct answer is B. 37. A battery negligible internal resistor is connected in series with resistor and the light dependent resistor or LDR as shown. The light extender is decreased. How do reading the voltmeter change? If the LDR is decreased, the reading voltmeter it will be increased. Why? Because the resistor L will be decreased and reading of voltmeter Q also. Oh, sorry. This is will decrease, but voltmeter increase. Yeah, because this is decrease in increase. Why? Because the voltage voltmeter here is constant. Yeah, the answer is C. 38. A radioactive nuclei formed by the decade nucleus then decay alpha emission, which grab the nucleus and plot against proton number Z, shows the beta mass decay followed by the alpha emission. The answer is C, yeah, because little bit going go to Z is adding some Z and after that going down from the 92 into 88. 39. What are the structure of proton and of the neutron quark? Yeah, up quark is 1, down quark is 2, up quark is 2 from the neutron, and down quark is 1. This is about different way. Yeah, it's opposite like 1 2 and they come to 1. The final question, what is charge of top antiquark? Yes, this is around plus 1 per 3. Okay, thank you very much for your watching my video. Don't forget like, comment or subscribe on my video. Thank you very much. See you on the next video.